Nearly 100 Russian troops were reported lost in a single day, while more than a dozen high-value targets, including air defense systems, fuel storage sites, and rear facilities, were struck within the same short window. That scale of damage is already serious, but the real story may not be the number of targets hit. It may be how those strikes were connected into a single chain of pressure. Areas that once sat far behind the front line are now being watched from above. Movement that once felt routine is now becoming the most dangerous moment. A soldier stepping out of cover can be tracked within seconds. A vehicle slowing down can turn into the first point of failure for an entire route. And once air defense systems are forced to react and reveal their positions, the sky above them becomes harder to control. The risk is no longer limited to losing men or equipment. The deeper risk is losing tempo across multiple layers of the battlefield at the same time, from frontline movement to supply flow and rear protection. Stay with this story, because what follows will show how a single drone strike can begin with one small target, then expand into pressure on an entire combat system. The real question now is simple, but difficult to answer. Is this just another precise strike, or is it the early sign of a shift in how this war is being fought? The most important shift in this phase of the war is that the danger no longer begins at the trench line, but deep behind it, where rear areas are now being pulled into the same hunt that once focused only on the front. What used to be considered distance is starting to lose its meaning because Ukrainian UAVs are reaching farther and staying longer over areas that were once treated as routine zones for movement and support. Positions that handled supply, staging, and short-term rest are no longer separated from risk, and that changes how every action behind the line must be planned. The sequence often begins without any visible sign of attack, and that is what makes it harder to read in real time. A reconnaissance drone appears high above the area, small enough to avoid attention, and quiet enough that those below may not even know it is there. It does not rush forward or dive toward a target. It holds position and watches. From that height, the operator studies patterns instead of looking for a single target. Roads that carry light traffic become lines of interest. Entry points to buildings begin to show repeated movement. Small groups that gather and separate leave a rhythm that can be tracked. Over time, this creates a picture of how the area functions rather than where a single person stands. Once that picture is clear, the space itself becomes the target. A vehicle that enters the area is no longer just a moving object, but part of a pattern that has already been mapped. A soldier stepping out of cover is not just exposed for a moment, but stepping into a zone that has been watched long enough to predict behavior. The drone does not need to act immediately, because timing becomes more valuable than speed. It waits for the moment when movement aligns with vulnerability, when a route narrows, when a group pauses, or when attention shifts away from the sky. That delay is not hesitation, it is control. As this continues, the distinction between front and rear begins to collapse. The same kind of observation that once shaped battlefield decisions near trenches is now being applied to areas that handle support and logistics. That forces a different kind of pressure because the threat is no longer tied to a fixed line. It follows activity instead. For Russian forces, this creates a wider burden than simple defense. Holding a position is no longer enough, since every movement behind it can be tracked and studied. Vehicles cannot move freely even when they are outside direct contact. Personnel cannot assume that a short relocation will reduce exposure. Every action leaves a trace that can be read from above. This is where the deeper effect starts to show. When rear areas are constantly observed, they lose the stability that frontline units depend on. Supply points become temporary. Movement becomes cautious. Decisions take longer because each step carries unseen risk. That slows down the entire system, not through direct destruction, but through constant pressure. In this environment, safety is no longer defined by distance, but by how little a position reveals over time. And when even that becomes difficult to control, the battlefield expands beyond its visible edges. So the question becomes harder to answer with each passing day. If the rear is now part of the same hunting ground as the front, where does a unit actually find a safe place to operate? The shift becomes even clearer when the focus moves from vehicles and positions to individual soldiers, because the hunt no longer targets only large objects but extends down to each person moving through the battlefield. An FPV drone does not need a convoy or a radar system to justify a strike, because a single exposed figure can now be enough to trigger an attack. Movement across open ground becomes the first point of danger, since there is no cover to break the line of sight and no structure to absorb the impact. A soldier crossing a field may believe speed will carry him through, but from above that movement stands out against the terrain and turns into a clear path that can be followed. Once detected, the engagement rarely ends at that moment. The drone closes in fast and low, and the target has only seconds to react, often without knowing where the threat is coming from. Even if the first attempt fails or the operator pulls back, the location has already been marked, and that mark changes what happens next. Trenches, which once offered a degree of safety, are now less reliable under constant aerial watch. A position dug into the ground still protects against indirect fire, but it does not hide the patterns that lead into and out of it. A soldier entering or leaving that trench creates a trace that can be tracked, and once that path is understood, the position itself becomes predictable. Buildings also no longer guarantee protection. A fighter may move inside to break contact and wait for the threat to pass, but the timing of entry and exit becomes the weak point. When a door opens or a window is used for observation, the moment of exposure returns, and that moment can be enough. A drone does not need to see everything inside. It only needs to catch the transition between cover and movement. Night conditions do not remove this pressure, they reshape it. Darkness limits what can be seen from the ground, but it does not fully protect against detection from above. Thermal signatures, movement patterns, and coordinated observation can still reveal presence, and once a position is identified, the strike can follow with the same speed as during daylight. What changes the situation further is that the drone observing the first target does not leave after a single engagement. It stays over the area and expands its focus, watching where nearby soldiers move, where they attempt to regroup, and which directions they choose when trying to escape the initial contact. That continued presence turns one event into a chain of exposure. As a result, the pressure spreads beyond the first individual. A small group nearby becomes the next point of attention, not because they were directly involved, but because they share the same space. Movement between positions becomes risky, and even short relocations begin to carry the same level of threat as crossing open terrain. This is where the deeper effect appears. The goal is not only to eliminate targets, but to remove the sense that quick adjustments can restore safety. When every shift in position can be observed and followed, the idea of finding a secure spot for even a short time starts to break down. Over time, the battlefield above becomes a constant layer of pressure that does not rely on large-scale strikes. It operates through continuous observation and selective action, turning small moments into decisive ones. If the sky is always watching, then survival is no longer about where a soldier hides, but about whether any movement at all can remain unseen. If this kind of pressure keeps expanding, the question becomes unavoidable. Is there still a way to move safely, or has movement itself become the most dangerous choice? The key point in this phase is that the target is no longer just a vehicle, but the flow behind it, because one disruption can ripple through the entire line that depends on it. Supply movement often appears routine on the surface, with trucks carrying troops, ammunition, and food moving along familiar routes close to the front. That routine creates a pattern, and once that pattern is understood, the convoy stops being a series of separate vehicles and becomes a single system that can be interrupted at its weakest point. The moment of contact is usually short and precise. A lead vehicle is identified and struck while moving through a section where options are limited. The impact does not need to destroy the entire column, because its real purpose is to break momentum. When the first vehicle is hit, the rest of the line is forced to react in seconds without clear information. Drivers behind reduce speed, some brake sharply, and others try to shift toward the edge of the road. That reaction compresses spacing and creates a cluster that did not exist before the strike. What was once a moving formation becomes a slowed and uneven group, and that change is visible from above. At that point, the situation shifts from a single attack to a controlled sequence. The reconnaissance drone does not leave after the initial hit. It stays over the area and continues to observe the response. It tracks which vehicles attempt to reverse, which ones get stuck due to terrain, and where troops begin to dismount. This continued observation turns reaction into exposure. Soldiers leaving their vehicles to find cover create new points of focus. Trucks that cannot move become fixed targets. Attempts to reorganize under pressure form small clusters that are easier to identify than a dispersed line in motion. The engagement area expands beyond the first impact. What began as a strike on one vehicle becomes pressure on the entire route, because every movement now feeds into the same problem. The road itself turns into a corridor of risk, where each decision leads to another point of vulnerability. As this unfolds, timing becomes critical. Supplies that were expected to reach the front are delayed or lost, and the units waiting for them begin to feel that gap. Ammunition may not arrive when needed, and reinforcements may not reach their positions at the planned moment. That delay does not always show as an immediate collapse, but it changes the pace of the fight. In many cases, the front line does not fail because it is overrun, but because it cannot maintain pressure. When support slows down, options narrow. Units that were preparing to move forward may be forced to hold position. Plans that depended on steady flow begin to lose alignment. The deeper effect is not just material loss, but disruption of coordination. A system built on timing starts to lose rhythm when one part is delayed. Even a short interruption can shift the balance during a critical window, especially when multiple actions depend on each other. From above, the battlefield no longer looks like a set of separate engagements. It becomes a network where each route connects to the next, and where breaking one link affects everything that follows. This raises a direct question about how damage is measured. Is the destruction of a single armored vehicle the true impact? Or is it the moment when an entire supply line slows down and forces the front to fight without what it expected? The next step in this sequence focuses on the air defense layer, because UAVs cannot move deeper and stay longer unless that protective shield is weakened first. Air defense systems are designed to detect, track, and intercept threats before they reach valuable targets, yet they also depend on visibility and reaction to do their job. That requirement creates a tension, because every time a system becomes active, it risks revealing its position to an observer that is already watching from above. The process often begins with quiet detection rather than direct attack. A reconnaissance drone identifies a suspected site based on terrain, layout, and movement patterns around it. The system may remain silent at first, which makes confirmation difficult, but the area itself starts to show signs of structured activity that do not match ordinary positions. Pressure builds when smaller drones move closer and begin to test the response. They do not always aim to destroy immediately, because their presence forces the system to make a decision. If it stays inactive, it risks being bypassed. If it activates radar or shifts position to improve coverage, it exposes itself for a brief but critical window. That window is where the strike is set. The moment a radar signal appears or a vehicle adjusts its angle, the location becomes fixed with greater precision. The response that was meant to defend the area becomes the signal that confirms the target. Within minutes, an attack drone is guided directly toward that position. The engagement itself is fast, and the result does not need to be total destruction to create an effect. Even partial damage can reduce coverage and force the remaining units to adjust. Once one system is hit, nearby elements face a difficult choice between maintaining their role or reducing activity to avoid the same outcome. This is how the pressure expands. One exposed unit leads to another, not through coincidence, but through the need to maintain protection across the same area. Each activation increases the chance of detection, and each detected position becomes a new point of focus. Over time, the network that was meant to provide layered defense begins to thin out in specific directions. From above, the change becomes visible as gaps rather than single losses. A sector that once had overlapping coverage starts to show uneven response. Some zones remain active, while others fall silent or shift their positions. That imbalance creates corridors where UAVs can move with less resistance and greater freedom. Those corridors are not permanent, but they are enough to change the next phase of the operation. Once a path opens, additional drones can pass through with lower risk and reach targets that were previously protected. The initial effort to expose air defense becomes the foundation for deeper strikes that follow. The structure of this approach is layered and deliberate. Detection comes first, followed by controlled pressure that forces a reaction, and then a targeted strike that reduces the system's ability to respond again. Each stage builds on the previous one, and each success increases the chance of the next. The result is not just the loss of equipment, but a shift in how the sky above the battlefield is controlled. Instead of a stable shield, it becomes a contested space where visibility and timing decide survival. This raises a question that goes beyond a single engagement. If high-value air defense systems must reveal themselves to function, and if that exposure can be used against them, can they still hold the same advantage when faced with constant, low-cost pressure from above? The most serious part of this sequence is not the explosion itself, but the list of targets that shows the strike has moved beyond the battlefield and into the system that keeps the war running. Fuel storage becomes the first point where this shift is visible, because it supports movement, power generation, and every layer of activity behind the front. When a drone reaches a tank farm and finds the right angle, the strike turns into a chain reaction that spreads across multiple containers. Flames rise quickly, and the heat forces nearby crews to pull back, which delays any effort to control the damage. The effect does not stop with the fire. Vehicles that depend on that supply face uncertainty, and routes that relied on steady flow must adjust without clear timing. Even if alternative sources exist, the disruption creates a gap that has to be filled under pressure, and that gap changes how operations are scheduled in the hours that follow. What happens next reveals a different layer of intent. The reconnaissance drone does not leave after the impact. It circles above the site and watches how the response unfolds. Fire crews move in, support vehicles arrive, and temporary routes form around the damaged area. Each of these movements creates new patterns that can be read and understood. That observation becomes the bridge to the next targets. Locations that receive traffic from the damaged site begin to stand out, and areas that handle maintenance or preparation become more visible. The strike is no longer limited to what was hit first, because the response itself exposes additional points of interest. This is where higher-value objectives enter the picture. A missile base such as an Iskander position represents the ability to project force at distance, and its infrastructure supports launch, storage, and control. When that kind of site is identified within the same chain of operations, the pressure shifts from local damage to a broader impact on capability. At the same time, facilities linked to drone operations, including preparation and repair areas associated with systems like Rubicon, become part of the same network of risk. These locations are not always on the front line, but they enable continuous use of unmanned platforms. When they are threatened or disrupted, the effect extends into future engagements rather than a single moment. The sequence shows a clear pattern. A strike begins with a target that supports immediate needs, then moves toward assets that generate future actions. Each step increases the depth of impact, and each exposed point leads to another layer that can be reached. This is not only about destroying equipment, but about shaping how the system behaves under stress. When fuel is uncertain, movement slows. When missile infrastructure is at risk, long-range pressure becomes harder to maintain. When drone support is affected, the ability to sustain aerial presence begins to change. Taken together, These actions create a form of pressure that works across time. It affects what can be done now and what can be prepared for later. The battlefield is no longer limited to visible positions, because the chain that feeds and supports those positions is now part of the same target set. That leads to a direct question about how to measure impact. Is the fire at a fuel site the main event, or is it the moment when a larger system begins to lose its balance across several layers at once? What makes this story so serious is that Ukraine's drones are no longer acting like isolated strike tools. They are starting to look like parts of one connected combat system, and that may be the real change now taking shape on this battlefield. This sequence began with reconnaissance. Then came detection. Then target tracking. Then the strike itself. After that came damage confirmation, and from there, the next target was already being pulled into view. In this model, Russian troops in the open can be hunted. Supply routes can be slowed down at the worst possible moment. Air defense systems can be forced to reveal themselves. And high-value assets such as Iskander-related infrastructure and Rubicon-linked facilities can be pushed into the same chain of danger. Once that happens, the real damage is not only physical loss. It is the loss of rhythm, the loss of safe movement, and the loss of confidence in the rear. The next question is how Russia adapts. Will it spread out more, hide better, move differently, and rebuild its defensive pattern fast enough? Or will this kind of drone pressure keep peeling away one layer after another? Do you think this was just one successful operation? Or does it signal that drone warfare has entered a new stage? If this breakdown helped make sense of the battle, please like, share, and subscribe to Military Force for more clear and grounded war analysis.